Well, hello. Well, in this episode of Finno-Ugric Machining, we are going to finalize this crafting press. We are going to make a handle, a crank for it. Well, I need to modify something on that design. And then we are going to make a wooden pedestal and then again add something to carry it with. I found this piece of, well, it's a handle I found in my trash bin, so to say. Okay, well now let's go on with the crank first.
Idiot.
Now that didn't go well. Maybe a shorter piece will do it better. Well, of course. And now, yeah. Well, I will thread this and face it and make a chamfer in there. This is not exact science. This can be really eyeballed. Yeah, talking of which, not too closely eyeballed. Well, that one. There will be a ball in there. It should go there without any trouble. Yeah. And it goes all the way as it should. Good. This had a tendency to drop in my chip pan. Oh yeah, okay. Next step, I will bend it. Okay, and now this rod should be bent, well, about here. Again, not exact science, but I wouldn't like it to bend like, I would like to be not exactly sharp bent, but not too wide either. So, well, lucky us, steel is a very poor heat conductor. So I can heat it quite locally there. And it should, well, it really should bend only on that place, but, well, hopefully this works. Who knows? So, I heat it up here until it's red, really. It feels like it would bend soon. A little bit more heat. Yeah, this works. Well, it's about 90 degrees. There you are. Wow. Well, not a bad one. Yeah, okay, there you are. Maybe there. Yeah. There you are. And it warmed up. And now I will take my bench grinder and level that thing there. So now here, this and that. Okay, let's go. Not very hard to do. It's almost done. Almost. A little bit more. Well, it heats up. A little bit more. There you are. Well, well, this is an 8mm drill. This is Loctite 648, and let's glue it there. Well, that drill goes there. It just prevents me from blocking the hole. And this is really very easy thing to do. Just some glue in there, and that's it. All around, like that. I don't think we need a lot of it. Something like that. And then I put this, simply put it there in the hole. And then I have this thing which I can check that it's straight, about straight. Again, doesn't need to be. And I would like to have there some paper or something, so that the glue doesn't go into the thread, into the gear. It seems to like to go down there. Oh, it almost did it. Did it do it? No, it didn't. Because it's awfully difficult to clean up from there. Okay, now I can let it cure. There you are. So, now this is, well, we have we have a crank here. And it, well, it looks alright. The proportions are quite alright. Well, it was my intention to put this one as a handle here on top. And it just doesn't look alright. It's, well, it's most likely a practical one, but it looks really bad. So, but if we use this, it's a round pin, so it repeats the round pattern down there. Yeah, and this is probably suitably long. Yeah, I think I can use this one. I just turn it round, and then I put some legs onto it, and then place it here. Okay, I'll make this one as the handle. Well, before continuing with my lathe, let's fix something. We have here is the oil gauge, and now side glass, and I can see that the oil level is quite low at the moment. So let's add. And in this lathe, you simply remove two screws here, and you don't drop them inside there. That would be not good. Yeah, and then you can get a plate like this away. And then let's wipe these surfaces clean here. And then we just add some oil. I'm using, this is 75 V90. This is gearbox oil, quite stiff for one. And let's add, let's see. Doesn't take a lot, this one. But yet you have to have it there. Okay, it's already starting to fill up. Oh yeah. That's okay now. It's filled. Oh, close the bottle. Yeah, now we have enough oil in there. And then I put this plate back here. And I'm super careful not to drop the screws again. This is the point when you drop them really. And these are actually quite tiny, so and you just place the screws there, you don't tighten them really tight. There you go. There you go. Wipe excess oil away and there you go. Yeah. Oil is filled, we are ready to go. Well, now we are ready to go with this one. This lathe seems to have a oiling system which is much like in a steam engine. It consumes the oil. It doesn't. It's consumed, and you never find it after it has been consumed. So this is very simple turning operation. I just put my workpiece here. It's already, the length of this is irrelevant, really. So, and these are essential as always. And yeah, then I'll face it. Let's tighten this tool first. That. And it's running about 800 RPM at the moment. Yep. And now I'm going to use a radius tool here. It's like this. It has a 5mm radius, which I will just make, not leave it like I don't make a chamfer here, but manually turn a radius there. Yeah, and now I just turn it. Oh, go away, I want to see. Yeah. Let's not be greedy here. I will pull it away from the chuck quite a long way, like this. Back here, and then just give it a... Okay. Well, not too shabby. It's okay. So, this is the grip I wanted to use originally, but, well, it has some dimensions which are suitable, like this gap here. So I measured it like this. I will make this 2 pieces from this, and now I'm just hacksawing. Oh, okay, 1. We need 2 of these. There you are. There you are. Well, okay. Now these 2 workpieces. Well, let's just start with those. There will be, about, well, 10 millimeters deep each side. Uh, uh, M6 thread. And that's it. It's a really simple thing. Of course they need to be like straight, etc. And of the same length. This is actually quite important. Yeah. Almost forgot. This is something you should never ever forget. I will make the other pin quite a lot shorter first. So I'm sure that the other pin, so that I can make them equal length. So I will be taking maybe 2 millimeters out from this now. There you are. That should be our 2 millimeters. Really fast. And then there is a sharp edge, and this time no radius, no chamfering, just remove the burr. Like that. Yeah. This doesn't need to be very deep, just so that it is there. And now it is there. 15 millimeters. That's 15. We don't need a lot of chamfering. Why does it? There you are. It made it really fast. Oh, wow, wow, man. There you are. M6 spiral flute tap. And now let's see. There is a suitable place. I believe. Put this in back gear so it doesn't want to turn on me when I turn this. And then we just make the threads here. So M6 threads all the way through. It's a little bit tight, so I back up a little bit so it doesn't break my tap into the, well, it's in the bottom now. That was fast, really. Oh yeah. Oh. Side number 1 done. Then just turn the workpiece around. Yeah. Okay. That's the first one. The second one will be, well, identical, but the second one I will now measure this one and make the second one exactly the same length. So when we put these under the handle, it won't be tilted. Yeah, And yeah, it doesn't need to be really exactly, but yeah. Oh yeah, well, that was fast. And we have threads all the way through. Yeah, there will be a screw like this. Oh. Screw like this in here. And this will be the underside. On the top side we will have all thread, and it will be well, hidden and glued into the handle. So the handle will be, you cannot dismantle it, but you can screw it off from the underside, the top plate. You will see how it goes, but it's the principle here is like that. Okay, now attaching this workpiece to the milling table. Well, yeah, it's very simple. I'm using these grooves to align it straight, but in order to not to mark these, I'm using this copper foil. Oh man, this is this copper foil, which is a little bit stubborn, about there, to protect it from being marked. So this is 0.1 millimeter thick copper foil, and now when I place it there, it will be there, like that, maybe, yeah, okay. And I'm using another copper piece on top of this to further protect it. Yeah, rabbit feet. And believe me, this is not like light. It's we just run it like this, and then oh, let's see now, one more time. Yeah, there is our place. So, this is now, so, well, 12 would be 3 revolutions from this, and then 1 millimeter more. 1, 2, 3, and 1 millimeter more. That should be our center. Yeah. Yeah. It's exactly where it should be. So, this time it will be 15 millimeters plus 3. So it will be 18 millimeters. So that's 10, 15, 16, 17, and then I look into my dial here, 18 is there. And this is just plunging into the material. This is very easy operation. And I'm running this 400 RPM, not more than that. We need to go deeper. That's it. I think, yeah, that's it. So now I zero my Z dial here, so I can make the other recess similar. And now we have this Z zeroed, so I can make this equally deep. There you are. Okay. That's okay now. 15 millimeters deep. How do I measure this one? Well, I need to think about that. 15 millimeters. Oh man. Well, maybe I can do it with this. So it would be 10 turns from this crank. Can I count to 10? Maybe I can. This is so shallow hole that I think I can drill this dry. So it will be like 10 turns from this crank. Okay, let's go. I first touch it so that I know where we are. There. And 10 turns. Wow. 1, 2, 3, 4, 5, 6, 7, 8, 9. I leave it to 9. I don't want to drill any deeper because, well, actually, I think a 5 millimeter deep hole would be enough in this case. I'm a little bit afraid that if I drill it through, the workpiece is ruined. Yeah. Then 9 turns. 1, 2, 3, 4, 5, 6, 7, 8, all 9. 9 millimeters. 9 revolutions, not millimeters. Each revolution is 1.5 millimeters. And now, well, this should be chamfered. Well, maybe the speed is alright for this. I just go and do this. Oh yeah. There is a chamfer. Quite good one actually. Okay. Then to 90 millimeters. There. And then I will do the same here. Yeah, there you are. Chamfer. So 2 M6 threads. Let's see if this is now at the correct. No. To lower it even more. As you can see, this builds up very rapidly. Okay, now it is there. And now we only need some cutting fluid and then we make a thread. Oh yeah. And this is a quite shallow thread, so I have to be. And this is spiral flute tab, and it's really practical for cases like this. And I need to be really careful not to bottom it too hard, because this is really shallow. Yeah, it's in the bottom now. Bam now. Yeah. These chips are really unawesome. Okay. Well, we are ready on the milling operations for this one. Next, some gluing. And yeah, I need to cut from all thread suitable pieces which sit there. So yeah, but okay. I have here some M6 all thread, which I will now put inside there, small pieces from this. So I start with beautifying the end of this thread in my bench grinder. It's really nothing much, just grind the end, rotating it just a little bit, and then the corner like that. Oh. Okay, now we have a beautified thread there. It should thread in quite easily into there. Yeah, it does. So the next step is to put it into my nice little vise. Not too tight so it doesn't crush the threads. And then I screw one of these here. Well, this is to measure where I should cut it. Because, okay, now it's bottom. And then this is now in 9 millimeters, so I set this about there. Okay, one is almost done. Then repeat the process with the angle, the bench grinder. Okay, does it go there easily? Oh yeah. Why? Looks to be all right. Good. And next one. So I did thread this out a little bit so that you get the Loctite all over the place inside there. So yeah. Oh. Oh now. Okay. And then I just force it in. Oh wow. That was not good. Okay. And this is almost ready. Well, now this is the top plate of this crafting press. And now I'm drilling two 9.9 millimeter holes here. I'm going to ream them to 10 millimeters. It's located so that the milling table slot is right under there, so I can drill through. Yeah. Away we go. Well, that's it. Two 9.9 millimeter holes. Okay, I reamed the holes to 10 millimeters, and now I will just glue this handle into those holes. This is a very simple operation. Well, just some glue here. Just some glue here. Yeah. Yeah, my first intention was to bolt this somehow, but I decided not to. So yeah, okay. Let's see. A little bit more. A little bit more. A little bit more. That one is okay, that one is a little bit more. Not that it would matter, but it's stubborn. Almost there. Well, it's good that it's tight. Doesn't come out, would hold without glue as well. Okay, there you are. Now just wipe the excess off and it should be there. Well, at this point it would be disastrous to notice that it's on the wrong side, but it's not. Shouldn't be. Yeah. Yeah. Handle is there and it will stay there after the glue has cured. Well, after a fruitful discussion with my wife, it was decided that a brake is needed for the height, for the cap adjustment, so that you can lock it on place. It seems so that when certain thickness is pressed, it has a tendency to open up itself. Not good. It shouldn't do that. So let's make a brake here. This is starts by putting a 10 millimeter pin here. It needs a 10 millimeter hole. So this is a 10 millimeter drill. 9.9 millimeter drill. And then we have a 10 millimeter reamer, which I will use to open it up to the final size. So, running this 120 revolutions per minute and feeding by hand. So, yeah. Well, we are done with that one. Well, okay. Off the camera I made this pin, which is a 10 millimeter pin, which is glued now into the hole. It's there, glued into there. And now there will be an eccentric part here, a roll, which is, binding this at the place, so it will break it. So now, what's the diameter of this thing that will go there? Well, I designed it in the CAD software so that it's around 20 millimeters, but I want it to be more precise than that. So I already measured the pin here, the diameter, and it's 1/100th of a millimeter undersize. Well, that's okay. And then I have here a feeler gauge, which I have now stacked so that it barely fits into there, into that gap. When it's clean, it should really go there. Yeah, okay. It barely goes there, and if I add a blade with additional blade with 5/100ths of a millimeter, it won't go there. So now I know that this is probably a suitable thickness, the gap between there. I measured it, and like this with a micrometer, just, and it seems to be quite exactly 4.5 millimeters. This means, so this gap here is 4.5 millimeters, and then the diameter of this is 10. So the radius of this is 5 millimeters plus 4.5 millimeters. So it's 9.5 millimeters radius altogether. So it's 19 millimeters diameter, this piece which goes there. And if it's exactly that, it should like barely be able to run in there. But I will offset the center of that hole, that thing, that roll, whatever that is called. I will offset it so that it's maybe 0.1 millimeter in the side, so that it will be free in one position, and when you turn it, it will bind the whole system. Yeah, okay. That's the plan, and well, let's go to the lathe and turn that piece without the hole. Yeah. Okay. This is, stock. It's, 20 millimeters in diameter, cold rolled mild steel, and now I'm going to face it. As simple as that. Like that. And then we come back a little bit and then we go. I'm still feeding this manually, but now I'm doing this by two hands. Way better. Yeah. The cutting oil and the slow feed made it. So this is smooth now. Well, now the diameter. This is 20 millimeter stock. So we need to turn, I think, 1 millimeter from the diameter. And so 0.25 millimeters cut here now. Let's see how this goes. My intention here is just to clean the surface so that I'm able to measure it. So then I know how much I need to go into tear. Well, there you are. Let's measure it now. Well, So it is 19.82. Is it? 19.82. To me it looks like that. So 0.82 millimeters to get off from that. And now I have slowed down the feed to 0.38 millimeters per revolution, so it's really slow feed. Now I pull it off before so yeah, and now we can just make sure that it's exactly 19. It should be very, very near to 19 millimeters now. Well, it's 19.15, and here it is 19.1, and at the very rim here 19.15. So 5/100 of a millimeter taper. Oh, let's see. I will actually try to get rid of that. Now, my friend file. Let's see. So more from this side. This really needs to be quite exact. So well, this is a very fine file, so it leaves a surface finish which is quite good actually. Well, now it's now it's 1/100 of a millimeter oversize here, and it's well, I didn't. This is now exactly correct at end. Did it turn my camera? No. So I need to take a little bit away from this end. And this is not a bad thing to do. It's very easy actually. Let's see now where we are. We should be quite near the correct dimension, and well, we are maybe no, it's okay. So now when I give it the Bear Tangue treatment, it will be quite exactly what I want it to be. Well, next step will be to turn a radius into this corner. It's just for the looks. This is just for the looks, nothing more. Go away. Go away. Oh, you have to be really careful with this one. This tool is super sharp. I sharpened it so that it really is sharp. Okay, we are starting to approach. I think that's okay. One thing that you can do with those is to overdo these. That's good enough. It's well, good enough. And now the Beartongue treatment, and then measure it again. There you go. Well, what do you tell? It looks really nice. Oh. And now, one more time, let's measure it. Now it should be really near our goal. Well, it is. It's 19 millimeters now. Oh, let's see how much taper did we manage to get there. Well, no taper. Good. Now this is 19 millimeters and now I need to cut it off. But I don't have a decent parting tool at the moment, so I need to do this with a hacksaw. Well, you might say that, oh man, yeah, I need to do it with a hacksaw, but before I can do that, I have to mark the correct place here so I can hacksaw it from the correct place. So let's see, this is now, yeah, well, the travel indicator stood in the correct place. So let's put our place in 22 millimeters. So there is, no, 23. And then I just come here back and simply face it until it's in correct length. And now let's put some mark there. There you are. By the way, this tool can break really easily in an operation like that. So you should be really careful when pluming it like that. But there is now our 22 millimeter mark. I will go and hacksaw this. Well, I don't. You probably don't want to see it. It's just, well, it's a little bit laborious because this is quite thick. Okay, now let's first face this hacksaw thing. Well, it's a little bit uneven. Okay. Not too much, actually. Is it okay now? Yeah, okay. So it's okay for measuring. So now I just take it away from the chuck and measure it. Let's see, how much is this? That's actually 21.75. Yeah, 21.75. Okay, let's put it back there first. There. So this is 21.75 and the pin is 20.15. So the final length for this one should be under 20. Well, if I make it exactly 20 millimeters, it should be alright. Let's take 0.25 millimeters per pass. There you are. Yeah, and the surface is really nice. Well, then take some of the burr away. We have a very, very sharp corner here. I would like to have that sorted out. It's very near the chuck, so I need to be extra careful here. There you are. Yeah. Okay, now let's measure it. Whether we got it somewhere in the neighborhood of 20 millimeters. Well, it's 400ths of millimeter undersize. No, 3. Nothing bad here. Well, next step will be to have a hole there, which is not in the center. I have now centered the workpiece in the vise, and when I rotate this around like this, well, there is some deviation, maybe 0.5 of a millimeter, also known as 5 microns. So now what I want to do is to, well, we don't want the hole to be in the center. I would like it to be 0.1 millimeter in the side. So we have the measuring instrument there. Let's put it 0.1 millimeter in the side, like that. Okay, there you are. And then, yeah, I also measured the side up and down, and it's straight there. It should be really straight. So now, well, let's drill a hole. Well, 9.9 millimeter hole and 10 millimeter reamer. Yeah. Well, I think we have done that before. Let's move over. We have some tools which are not very needed here. What we need is cutting oil. Okay, here we go. And this is now running, oh, wait a minute, 120 revolutions per minute. And I'm feeding this manually. Again. Very carefully, actually. I don't want to put any pressure on that workpiece. Okay, now it's cutting already. Yeah, this is a split point drill, so it should not wander. But you never know. Oh yeah. There you are. One workpiece with a hole not in the center. Well, it succeeded quite well, I should say. So this is now, it goes there like that, and it's there is no slop, of course, reaming and having a quite exactly 10 millimeter pin. So what possibly could go wrong? Well, everything. For example, that hole would not be straight, would not be in the correct place, etc. Okay, so now when this is turned like this, it grips at some point there. And now if you try to rotate this, it will rotate this even more, and it will tighten it really tight. Okay, and well, yeah, well, it works. It really works. So what we need here is a lever, and now the place for that one should be so that it is pointing downwards when it's not locking. So that's one extreme. I make a marking here, and that's another extreme. And as you can see, it's well, it's halfway. So I would actually like it to be maybe there. Not exactly on the middle point, but a little bit so that when so that the lever doesn't come on the way here. Yeah, it shouldn't. Now it shouldn't. So now I know that the lever should be somewhere from that direction. Okay. Well, we need a hole into this workpiece, and then we also need to make the lever. Oh, yeah. Here is the brake in position, ready to be drilled and reamed for the lever. Yeah. Yeah, and away we go. Five, and it's true actually. Just a little bit more. Yeah, it's true. But that was fast. Yeah, it's true. Okay. Then just the reamer. Well, I think this is too little. Well, it might be good actually. But I need to progress really slowly. Okay, I progress. Let's do something here. High gear. And then I change the speed somewhere lower. Now it's around 300 revolutions per minute. I think that's okay. And a lot of lubrication here. Let's go. Well, let's take it away from there. I can do this manually somewhere else. I don't want to push it against the... Oh! Oh! Went there. Yeah. The reamed portion is there, and it's all the way reamed. Very nice. Yeah, Next step, making the handle for this lever. Now, the last piece of this puzzle, the brake handle. This will be sort of freehand turning. And I would, let's shut up and just make this. Yeah. And now just something, some grinding in bench grinder, and this will be ready to go into the place it's intended to go into. Okay, now gluing this handle into this hole where it belongs. And I'm using this 10mm drill to prevent it, position it correctly there. Okay. And this is a little bit delicate operation in a way that when I put this into there, I cannot leave the drill into that hole because it will glue the drill in place. And don't ask where I know. It really glues it there, and that's not a good thing to happen. But okay, let's have some glue in there, and now it is there, and I just pull this away, and then I hope it doesn't move, and now I let it cure in all its glory. Finally the crafting press is ready, and it didn't involve woodworking. We had this really fruitful discussion with my wife, and she told me that she wouldn't use it if it would have a large pedal which would be always on the way, etc. So she decided to use it on an edge of a table. Well, if that is the case, so who am I to tell her that there must be a pedestal for this one? Okay. Well, in the next episode of Finno-Ugric Machining, there might be demonstration what she does with this thing, and let's see, that might be, and then I really don't know what it will be, but it always will be something. That's the case. I cannot be without doing something. So, till next time, bye!